Now let's go to the topic electric field intensity due to dipole on axial line. This question is very important for 4 marks. So many times asked in the public examination. Look here, what is mean dipole? Dipole mean two poles. Di mean two poles. Two. One is minus q and plus q separated by some distance, that is called dipole. Okay, especially if suppose we take the conductor, we know that it has so many number of free electrons. Suppose AC voltage is given at the midpoint, then due to that electrons are shifted one side. Okay, suppose all electrons are gathered at this the corner, it acts as a minus q. Definitely other corners it is a lack of electrons. Okay, so it acts as a plus q. So AC voltage mean again here current is continuously changed, voltage is continuously changed, that is minus plus, again minus become plus and minus. AC mean alternating changing. Okay, so due to that again electrons are come to this side, so again it acts as a minus q and this end is acts as a plus q. So electrons are oscillated due to AC voltage. Due to that electromagnetic signals are generated. Remember, when charge is oscillated, due to that electromagnetic signals are generated. Okay, suppose we take the mobile. So there is a small dipole at the corner, at the top of the corner. Due to that it generates electromagnetic signals and also receive the electromagnetic signals from the tower. Okay, so we have to study about these electric field intensity at the starting the level. So we take very simple manner, that is electric field intensity on the axial line. So what is axial line? That means a line which is passed through the two poles. So this line is passed through the two poles, so this is called axial line. Minus q plus q. Okay, minus q plus q separated by some distance, that is called dipole. Now where is the dipole located? Look here, we take dipole located at exactly midpoint of these two, midpoint. So dipole is located at the midpoint. From midpoint plus q at a distance a, similarly from minus q at a distance a. So here two poles are separated at distance 2a. To find the electric field intensity known about the dipole momentum. Dipole moment. We want to find the force, we have to study about momentum. Momentum is need to find the force. Here also dipole momentum is need to calculate the electrostatic force. Electrostatic force is nothing but here electric field intensity. Electric field intensity is nothing but electrostatic force applied on unit positive charge at a distance. Okay, look here. Now let's go to the discuss about the dipole momentum. It is depend upon pole strength and distance between two poles, that is 2a. So dipole momentum is product of charge and distance between them, that is 2aq. Dipole momentum is denoted by lit, so p is equal to 2aq. Now we want to calculate the electric field intensity on axial line. So this is the axial line. Suppose the point P is here, okay, which is at a distance from the dipole, that is r. So from dipole P is at a distance r. So in dipole there are two poles. So here one is plus q is located here and minus q is located here. Okay. So we want to find the electric field intensity at the point P. That means unit positive charge is here. Okay. So test charge is here. We assume test charge is here. So due to plus q, plus 1 is repels along this direction. Due to minus q, plus 1 is attracted toward this side. So both are in opposite direction. Okay, so resultant is subtraction of E plus q and E minus q. Now we want to calculate what is the distance between plus q and P. Look here, from midpoint it is at a distance r. Okay, and from midpoint plus q is at a distance a. So suppose this length is cut, then we get this length. Okay, so cut means subtraction. So this is r minus a. So from plus q, P is at a distance r minus a. Look here, from minus q, from minus q, so what is the distance? From dipole, it is at a distance r. Again, this distance is a. So we add these two distance, then we will get from minus q to P. So that is r plus a. So from minus q, P is at a distance r plus a. Okay, what is E formula? That is 1 by 4 pi epsilon naught q by r square. We know that. Okay, so this is formula for electric field intensity. So there are two poles. One is plus q. E due to plus q. So we will get 1 by 4 pi epsilon naught q by, what is the distance? Look here, r minus a. And E due to minus q, that is 1 by 4 pi epsilon naught q by, that is r plus a whole square. Okay, now distance is r plus a. Look here, on point P, E plus q, E minus q acting in opposite direction. Okay, so E resultant is E plus q minus E minus q. Okay, because here electrostatic field intensity are in opposite direction. Okay, so this is E plus q, E minus q. Remember, E electric field due to minus q would take actually here minus. Due to plus q, suppose this is the direction, due to minus q, so this is direction. So minus here, nothing but here direction. Okay, or we take the modulus. See here, under modulus minus become also plus. So these are in opposite direction. So we get the subtraction. So E resultant is 1 by 4 pi epsilon naught q by r minus a whole square. So this is E plus q minus E minus q. What is that? 1 by 4 pi epsilon naught q by r plus a whole square. Next, E resultant, that is equal to, look here, 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught q is the common on both sides. So we get here q by 4 pi epsilon naught, that is 1 by r minus a whole square minus 1 by r plus a whole square. So E resultant is q by 4 pi epsilon naught. Look here. So what is the LCM? These are two odd numbers. So denominators are odd numbers. So LCM is multiplication of these two. that is r minus a whole square into r plus a whole square. Look here, r plus a whole square into 1, that is r plus a whole square minus r minus a, okay, whole square. E resultant, that is equal to q by 4 pi epsilon naught. See here, expand these two, finally we get 4ar. 4ar. We know that r plus a whole square is nothing but r square plus a square plus 2ar. R minus a whole square is nothing but r square plus a square minus 2ar, and these two terms are subtracted, then finally we get 4r. Okay, directly you take this one. In the denominator, r minus a, r plus a has square, so we take the common, that is r minus a into r plus a common square. Okay, next, E due to dipole, due to E resultant due to dipole. Okay, so ER mean electric field due to dipole, that is q by 4 pi epsilon naught 4ar by, look here, r minus a into r plus a, that is r square minus a square whole square. Okay, now rearrange of all these terms, then we get 1 by 4 pi epsilon naught 4aqr by r square minus a square whole square. Introduce one of the formula. 2aq is equal to what? P. Look here, aq is there and 4 is nothing but 2 into 2, 2 into 2, so that is 1 by 4 pi epsilon naught 2 into 2aq r by r square minus a square whole square. Okay, so this is electric field due to dipole, due to dipole, that is E resultant. Okay, sorry, E resultant, so that is 1 by 4 pi epsilon naught 2aq is nothing but P, 2pr by r square minus a square whole square. Okay, so this is electric field intensity due to dipole on axial line. In many situations, mobile is too away from the tower. Okay, from the tower mean, that is R. So mobile, there is a small dipole system. So compare this distance, R is much larger. So R square become so much larger, a square. Okay, in such a case, a square is negligible compared with r square, so this term is removed, especially in for this condition 1 by 4 pi epsilon naught 2pr by r square whole square, that is r power 4. So here r by r power 4, that is r by cube. So E resultant, that is equal to 1 by 4 pi epsilon naught 2p by r cube. So this is formula for electric field intensity due to dipole on axial line.